Hi, I'm Preetha Chatterjee, and in this presentation, I will talk about our work on automatically identifying the quality of developer chats for post-hoc use.
So analyzing the quality of information in a mining source is essential and the first step to building effective data-driven tools, such as building API recommendation systems, enhancing quality of search engines, etc. So one of the software artifacts, Stack Overflow, which is a popular Q&A forum, has been mined extensively to build this kind of data-driven software tools. And for example, in Stack Overflow, there is already built-in mechanisms for quality assessment in the forms of accepted answers, vote counts, etc. And beyond all these built-in mechanisms, there is also a body of research which focuses on analyzing the quality of information through measuring conciseness of answers, code readability, etc. However, none of these built-in mechanisms, neither any prior research has been made to assess the quality of information in chats. And in this part of the talk today, I am going to focus on my work that actually focuses on techniques on how to automatically analyze quality of information in chats. Okay, so I'll start with another example here. So conversations in developer chat platforms vary considerably in quality. And to understand that the notion of quality or what we mean by quality of communication in chats, we are going to look into this conversation. So here, for example, Alexia asks a question about formatting text in a file. And Alina responds with a regular expression as a potential solution, along with an explanation of why that suggested solution would work. And at the end of the conversation, we also see that there is an indication of answer acceptance. So overall, this conversation is concise, it's easy to read and understand, it has all the details of the problem and the solution. And finally, at the end, the indication of the answer acceptance gives us some confidence on the information that has been included in this conversation. So intuitively, this conversation is of good quality. Now, to compare, let us look at a separate conversation. So this is actually a very lengthy conversation, and I can only show you a part of it here due to space constraint. So the conversation starts with Cody trying to ask a question about how to implement an algorithm in Python. And as you can see here, that the question does not contain all the relevant details for someone else to give a concrete answer to this question. And as a result, there are a lot of follow-up questions. There is so much noise in the conversation. And ultimately, we don't even find a concrete answer to this question. So overall, the sheer length of the conversation accompanied with the noise and lack of the relevant details makes it very difficult for a reader or even for an automatic mining tool to extract relevant information from this conversation. So therefore, this conversation is intuitively of poor quality when we compare it with the last conversation that we saw on the other slide. Now, to automatically assess the quality of conversations in developer chats, we actually took a data-driven approach. We recruited human judges to analyze the quality of 400 developer chat conversations. And based on the results of that study, we found that a conversation is considered post hoc quality based on the availability and ease of identifying information to gain useful software related knowledge. So what this means is that we consider any conversation as post hoc quality if it contains information which is useful for readers or automatic tools after the conversation has ended. And we are calling it post hoc quality because we are analyzing the quality of the conversations not in real time, but after the conversation has ended. Now, so next I'll talk about how the automatic approach to detect quality. So basically, we formulate this problem as a binary classification task. We start by extracting 5 sets of features from each of the conversations in our data set. And then we use several supervised machine learning based classifiers, such as logistic regression, a couple of ensemble based classifiers, such as stochastic gradient boosted trees and random forest. So, for example, these two classifiers have been good at doing related software related tasks, such as analyzing quality in Stack Overflow, for example. And we also did train a simple sequential neural network. And finally, we predict the quality of a conversation in binary, so whether that is a post hoc quality or not. So now that we have an overall understanding of the problem formulation, let us take a closer look at the features that we are investigating to identify post hoc quality. So first, we start with analyzing the form of the conversation. So for example, we see that does the conversation start with a primary question? Does it have any indication of answer acceptance, etc.? Now, next we move on to understand the content in the conversation. So for example, we see that is there any code segment included in this conversation? And if it is the code segment accompanied by a small, short description? Because the hypothesis here is that it is easier to understand a code if it is accompanied by a short description. Next, we move on to analyzing the structure of the conversation through several features. For example, we look at some of the features which are related to length. So for example, how many utterances or messages are there in the conversation, number of sentences, number of words, etc. Then we see that, okay, how well written the conversation is. So for example, we investigate several readability metrics such as Coleman-Liu index. So this is basically to assess that how easy it is to read and understand information from this conversation. And finally, we look at participant experience. So this is similar to the user reputation notion in Stack Overflow. So the hypothesis here is that the higher the knowledge or the more experienced the participant is, the higher is the quality of information provided by that participant. Now, moving on to the evaluation of this. So we evaluated our technique over a set of 2,000 developer conversations curated from 5 different programming communities on Slack. And in the gold set, which is a manually annotated gold set, we see that there is a 1,310 post hoc quality conversations, while there are around 700 non-post hoc. So this shows that our data set is a little bit unbalanced. Now, we actually investigated 3 research questions, and I'll talk about them one by one. So the first one is that how effective are the machine learning based techniques for automatic identification of quality? And apart from all the machine learning based classifiers that we saw before, we also designed 2 heuristic based baselines to compare the results to our machine learning based techniques. And here on this slide here, you see the graph which shows our evaluation measures, F1, area under curve, AUC, and Matthews correlation coefficient for each of the techniques that we have seen before. So from this graph here, we observe that the machine learning based techniques outperform the heuristic based baselines in all the evaluation measures, specifically for MCC, which actually adjusts for our unbalanced data set. And we also observed that although most of the machine learning classifiers do reasonably well, The sequential neural network provides best performance with an F1 and AUC of 86% and an MCC of 55%. Now we move on to the next research question. So here we are doing a feature analysis to understand which features result in more effective automatic identification. And to do that, we calculated the information gain for all the features across our feature sets. And on this table here, I show you the top 8 features which has the highest information gain. And we observe from this table here that the features which are most effective for automatic indication, quality identification are often related to length, and is also related to the coherence of conversations. So we calculated the coherence by actually creating graphs for each of the conversations in our data set, where each utterance is presented as a node with weighted undirected edges in between them. So for example, the higher the average graph degree, that means the utterances are more connected, and that indicates that the conversation is more coherent and possibly consists of less noise. The other features are related to topic of discussion. And finally, we see that the participant knowledge is also essential for effective automatic identification. And this also actually confirms our hypothesis that higher the participant knowledge, the better is the quality of information in a conversation. Now, excuse me. Now I will move on to the final research question of this study. So in this research question, we try to understand that what types of conversations are difficult to automatically detect as post-hoc quality using our techniques. And to do that, we basically did a classification error analysis, and we calculated the false negatives and the false positives across all the techniques. And then we did a manual analysis of the ones which are the false negatives that is in the intersection of this Venn diagram for across all the classifiers. So from the manual analysis, we found that the major or the most significant reason for the false positives is that our classifiers often struggled distinguishing conversations based on the quality of answers. So that means sometimes answers are provided partially, and even in some cases you will see that there are conversations where answers are provided, but later on someone comes back and says, oh, that answer did not work. So at this point, our classifiers cannot understand the overall quality of the conversation, since we are not doing a specific analysis on the quality of answers per se. And then for the false negatives, we saw that the most significant reason was often that they were very short conversations, 3 or 4 messages, and that did not provide enough content for our features, and thus were difficult to be automatically detected as a post hoc or a non-post hoc quality. So in summary, this work is about creating a machine learning based approach to automatically identify post-hoc quality developer conversations. And this work takes the first step in assessing the quality of information in chats and opens up several opportunities for other tasks related to software maintenance, such as efficient information gathering for building software maintenance tools, enriching existing knowledge bases, and community knowledge.